Hey there. This is going to be the third status update for my independent study on paper recommendations. This is likely going to be the last status update. I will have another presentation that I'll give on this uh, sometime towards the end of April, just because the course is wrapping up. The state of the application is pretty good. There's some stuff on the front end I want to clean up, but um, we're in a good spot moving forward. Uh, so last time I went over the backend API that I created for this. Not too much has changed. Most of what has with the backend relates to the Milvus instance. So before I had it indexed and created this params right here, it basically creates like a k-means cluster for the different embeddings. And then when I was searching for similarities, I was trying to pull just the papers in the references, but it was querying all of the papers in that k-means cluster and returning the top 20 when the 20 I wanted were specifically, certain papers. So I stopped using the Milvus functionality for search and instead just directly query. Let's see where it's at. I directly query the embeddings, and then just since I normalized the values before pushing them to the database, I just have to do the dot product or inner product to get the cosine similarity for however many papers. So on the back end, that's all that's changed. Um, so since the last update, I've mainly been focusing on creating a front end visualization for this. So here, if we find a paper, this right here, I created a real simple like autocomplete with one of OpenAlex's endpoints. This definitely needs improvement. It's one of the things I plan on focusing in the coming weeks. But if we find similarities for the yellow V3 paper, because I've ran it before, um, it will pull up all of the details. This is using Helios Web. Let's see, is this one yellow? No. Where is it? Interesting. Yeah, like I said, it still needs cleaned up in some aspects. Let's just go down to 2 so I can figure out what's what. So here we have the original Yellow V3 paper that we entered and its direct references. So for the root node, we should only see the paper title, but for subsequent nodes, we'll see the similarities. So we have a parent and a root similarity. The parent is the paper that references the paper we're pointing at. The root will always be how this paper compares to the one that we selected up here. The size of the node is determined by an average of the parent and root similarities, and then the color is determined by the size. So all these have very low similarities, so they're very similar in color. These two should be pretty close. Yeah, they're in the 50s. Then we have 30 and 83. So from there, what I can show you right now easily is if I double click one of these, we will be taken directly to OpenAlex's URL for the paper. So if we don't fully understand the content of YOLO v3, we can enter it, and then we can directly see its references and how they correspond, how they're similar. And the idea behind this is that if you don't fully understand YOLO v3, well, here's everything that it references. Maybe if you read some of these similar ones first, it will help you build a foundation up to the paper you're wanting to read. So I will go back to attention is all you need and run this to a depth of 4. while I'm here, the depth slider, like you saw before, 2 is just a paper and its references. 3 would get these papers references. 4 gets a fourth layer of references, and I've never successfully ran 5 because for attention is all you need. I know I tried running it and it resulted in like 80,000 papers being ran at once, and that just took a really long time. So I have ran this for 4 before, so that shouldn't be too bad. But while this loads, let's take a look at the code for the front end. So here's the autocomplete feature. It's really basic. There's not really much to show right here. I essentially get results from whatever's been typed so far from OpenAlex and then just display it as a list. That's all there is to it at the moment. This will need cleaned up. My current aim is to make this visualization full screen and then create a little modal over here in the corner that will have basically the search functionality and some customization options. Like this is currently the color scheme cool. I want you to be able to change it to whatever color scheme you want to use. So there's a couple different ones that are readily available in D3, and I'm probably just gonna make it so you can choose any of those. Back to the code. Moving on to the visualization. This is everything that interacts with the backend I created and Helios. So we fetch the root paper. Right here you pass a paper and it will return the references in the format we wanted. This will create all of the embeddings and save them to the Milvus instance whenever you pass a list to this method. This will get similarities based on a target and the sources. And then it will also compare all of the sources to the root. And that's how we get the root and target sources for each of them. Here kind of ties together all of getting the references to a certain depth. So for the depth of 4, we would go through and get all of the references, and then it returns a map. The map will relate an integer to the depth layer. So layer 0 is the root, and it'll only have attention is all you need. Layer 1 will have its references, so on and so forth in that matter. We then have to get all of the similarities, which this takes care of. Yeah, this tooltip I basically copied and pasted from Helios Web's example because I'm not very good at JavaScript. I had to basically reteach myself all of it to get this up and running. Yeah, so here we set the color. This will hopefully be changed in the near future so that you can set it to whatever color scheme you want. We call all of those functions I showcased above. We format the data in the way that we want for Helios, and then we set up the instance. These are some basic variables to help us out later. Here we calculate the node size based on all of the edges where the node is the source. If there are no edges where the node is the source, then it's just 1 because that's the root node. So then we calculate the total weight and the total root weight, which is just the we add up together all of the weights of the source edges and all the root weights. We get the average of those, and then we set the weight for the node to the average weight and average root weight. Well, the average of those two, the average of the averages. Let's see. This finds the target. So I'll talk about that a little bit once we get back to the visualization. This just sets the node colors using D3. Here is showing the tooltip whenever you hover over a node and getting rid of it when you're not. If you click on the node, you'll center on it. I'll explain a little bit more about that later. Double clicking to open it in open the paper URL in a new window. Centering on the edge, and that's just debugging. So that is like a really brief overview of the code. Helios makes it really simple to do a lot of this. Yeah, it's pretty nice to work with from what I've experienced so far. It took me about a week to figure all of this out once I remembered how to write JavaScript. So back to the visualization. Let's zoom out. So over here in the console, there are 3,200 papers displayed here and 8,500 roughly connections between those papers. So it quickly balloons. Like I said, if I would have done depth 5, it would have tried to run this for 80,000 papers. So what I was mentioning before with the center, if you click on one of these, it will center on this, so you can then, get a bit more granular with where you're at and what you're trying to currently look at. What I was saying before with the size, this size is calculated, well, the size of this node is calculated by taking that average weight and multiplying it by the size of the previous one, or the one that you're targeting. So since this is a source targeting this one right here, and it's at 11%, this node should theoretically only be 11% of this one. And that's how it works all the way across the network. And then the color scheme is determined by the size as well. So in this color scheme, the green ones and yellow are higher similarity scores. Basically the highest with respect to the root paper, which is somewhere in here and I will not be able to find. But let's take it back down to 3 real quick and rerun it. This should be fairly quick because there's not near as many papers. Yeah, we've already got the map back. 300 papers, 424 edges. So we zoom out. Here's the attention is all you need. I'm not sure why there is a parent similarity to itself. It's interesting. I'll have to look into that. But for example, here's attention is all you need. Here we have, I just saw LSTM somewhere. I'm not sure what blue is, but that's a good example to, something that's similar and you could read next. But yeah, overall, it's in a pretty good situation. There's some tweaking I need to do and some more stuff to make it look nicer. But it functions as I was hoping. Future improvements, something that I'm probably not going to have time for with the remaining time in this class. OpenAlex also has an endpoint for creating or for finding what papers reference for, say, attention is all you need. Felipe pointed that out. I would like to do that. I don't think I have time anymore, so I'm just going to focus on making this nicer, and then maybe in the future I'll add that functionality to this project. But yeah, time will tell. We'll see. I'm happy with the way everything's turned out so far. This is pretty much exactly what I was hoping for when starting this project, because we have a visualization of the similarities between papers, and it tells you what is going to be more helpful than others. For instance, this is evaluation of summaries using Ngram. That's NLP. That's useful with attention is all you need, but it's not really that related. And the same for a lot of these. And that was the main goal I had when trying to take on this project, is be able to see the references and what you should read before you get to the paper you're wanting to. So like these three would be pretty helpful, but not as much as some of the direct references, more than likely. But yeah, that's where we're at. In the coming month, I'm gonna focus on cleaning it up, and yeah, I should have a presentation late April or early May over the entire thing, whereas this one just focused over the front end portion. Yeah, that's all I have for now, and I'm always open to feedback, so if you have any, let me know. And thanks for watching.